Welcome to the Las Vegas Casino project. In this section, we'll be working through a project which enables us to practice our object-oriented programming skills. So we've seen in the last few sections what classes are, what class attributes are, how we can create methods. We looked at modules and packages, but this won't be that relevant for this project, but then we did cover some errors and exceptions handling content which may be useful as well. So let me provide an overview of the project. Las Vegas Casino have approached us to create a new online game. They would like us to produce a version of the popular casino game 21. Now for the purposes of this game, the game will work as follows. We start with a standard deck of cards, and then 2 cards are dealt to the player and 2 cards are dealt to the dealer. Each card in the deck has an associated value. So if a card has the number 2 on it, the value is 2. If it has an 8 on it, the value is 8. If it has a jack, queen or king on it, the value of the card is 10. And if it has an ace on it, the value can either be 1 or it can be 11, depending on the combined value you have in your hand. Now the idea is simple. You sum up the value of the cards that you've been dealt, and the objective is to get closer to 21 than the dealer, with the trick being to not go over the value 21. If the value of your card sums to 22 or more, then you bust and you lose the game. Now a player can choose to hit or stand depending on their value. So if their combined value starts at 12 because they get a 4 of hearts and an 8 of diamonds, well then they can hit, which will then allow them to take another card from the deck. If they then get 6, well then their combined value is now 18 and they have the decision whether they want to risk it and hit again or if they want to stand because they're happy with the value 18. Now the dealer on the other hand will continue to hit until the combined value of their cards sum up to 17 or more. So we may want to break the application down as follows. We're going to need to think about how we can create an object that deals with a standard deck of playing cards. So firstly we'll want to create a deck, and we'll also want to have the ability to shuffle the deck and to deal cards to the player and the dealer respectively. Now seeing as this game is for a Las Vegas casino, we want the player to be able to gamble and bet using chips. So we're going to need to think of how we can ask a player for their bet and then keep track of the chips that they have available. Now it wouldn't be fair if the player could see both of the dealer's cards, because they'll have an idea as to what the value is and whether to hit or stand. So we're going to want it so we can only see one of the dealer's cards at a time and the other card is hidden. Obviously the player will need to see both of their cards to establish whether to hit or stand. We need to create functionality that will deal an extra card if a player does decide to hit, and we also need to create some conditional statements that checks to see if the value is greater or less than 21, and ultimately if the player is closer to 21 than the dealer. Depending on the winner, we'll need to adjust the player's total chips if they've either won the round or lost the round. And then after they've played a specific round, we'll want to ask the player if they want to play again. Now there are so many ways that this game can be created, and the Las Vegas Casino is looking forward to seeing what you come up with. Remember, there is no right answer, but when you get to the point where you're testing your game's workflow, you want it to be as user-friendly as possible. Now the objective of this project is to practice what we've learned with respect to object-oriented programming. So think about how we can use classes to create data structures that deals with some of the problem statements at hand. For example, you may want to create a class that deals with a card itself. But rather than providing clues, dive straight into this project and see how you get on. If you get stuck along the way and can't progress any further, don't worry, in the next video I'll be walking you through my solution to the Las Vegas Casino project, where hopefully you'll pick up some hints and tips along the way to then apply into future projects that you embark on. So with that being said, good luck and I'll see you in the next video. Welcome to the Las Vegas Casino project solution video. How did you get on in creating the popular casino game 21? Now, if you managed to create a working solution at the end, whether it took you 10 minutes, 2 hours, 2 weeks, congratulations on applying your new Python skill set to create something which arguably on the surface would be very difficult to produce without knowing a coding language like Python. Now, if you didn't manage to code up a solution, don't worry, this is exactly what this video is for. We're going to walk through a solution step by step, and hopefully you'll pick up some hints and tips along the way so that you can apply them in the next project that you embark on. Now, like I mentioned in the last video, there are so many ways we can go about doing this, and the way I'm about to show you is a way that it can be done. The important thing to achieve by the end of this video is understanding each code line that I write, so you're familiar with the Python capabilities that I'm leveraging in order to get a working solution. So let's get straight into coding up the game 21. The first thing I'm going to do is create an import section, which is where I will place the imports for this game. Now at this moment in time, I'm not quite sure what imports I'm going to need, so I'm going to leave it blank for the time being. But this is where I'll put any library that I feel is useful to utilize in this code. The next thing I'm going to do is create a section called Global Variables, and this section will simply store variables that I want to reference later in my code. And the reason I put these at the top is because I'm going to need these defined first so that the rest of the code can utilize them accordingly. Now the card game 21 is predicated on a standard deck of cards, so we're going to need to tell our game what these cards are. So my first thought is, I'm going to need an object that stores information about the cards. And we know that cards have suits, cards have ranks, and cards in the card game 21 also have values. So the first thing I'm going to do is create a variable called suits, and I'm going to set this equal to a tuple. And the reason I'm using a tuple is because I know that the card suits never change. We won't need to change this at any point in our code, so therefore we can use an immutable object, which we know a tuple is. So in the brackets I can pass in 4 strings: diamonds, hearts, clubs, and spades. So we have our suits defined. Next, we'll set a variable called ranks, and what the ranks will represent is simply the face number of the card. So we know we have 2 through to 10, we then have a jack, a queen, a king, and an ace. And once again, these ranks never change. We always have these ranks in the card deck. So once again, I'm going to create a tuple, and I'm going to put the strings 2 through to 10, and then I'm going to put a jack, a queen, a king, and an ace. So at this point we have 2 variables, suits and ranks, and this would actually enable us to create a full deck of cards if we were to perform a loop over our suits and a nested loop over our ranks. And this will be something that we see in a minute. The next thing I'm going to do is create a variable called values, and we know that each rank in our card deck, i.e. 2 or jack or king, it will have a value. Because based on the rank of a card in the card game 21, we need to sum the 2 values that we get to ascertain whether we think we're closer to the value 21 than the dealer. So what would be a good data structure that we can use to store this information? Well, the first thing that comes to my mind is a dictionary. Because what we can do is we can have the key of the dictionary representing the rank itself, and then we can pass in an integer into the dictionary, which will be the value associated with that respective key. So we can put the first key as the string 2, we can then put a colon, and we know that the value associated with the key 2 will be 2. I can do the same for 3 through to 10. Now, as mentioned in our previous video, jack, queen, and king will all have the value 10 in the game 21. So we can have the key jack having the value 10, queen also having the value 10, and we can have king with the value 10. Now we also need to include the key ace, and we're going to default this to the value 11 to begin with. Now I did mention that depending on the cards that a player is dealt, an ace could represent a 1 or an 11 depending on the player's preference. But we're going to default the value of an ace to 11 to begin with, and then later in our code we'll address the case where it needs to be a 1 if the sum of the cards that a player has is greater than 21. Okay, so this is our suits, our ranks, and our values now defined for our deck of cards. Fantastic, we can now move on to actually creating a deck of cards. So I'm going to create a new header which separates this next section of code, and I'm going to label this Logic to Create Standard Playing Cards. And my intention here is literally that. I want to create a standard deck of playing cards, whether I'm playing 21 or Rummy, whatever the card game is, I'll be able to use this object in any card game that uses a standard deck of playing cards. Now sometimes the confusing thing is to know where to start. Where do we go from here? But my first thought is, in a deck of cards, if I pick up a card, I'm picking up an object. I'm picking up the card itself. And this card tells me a few things. It tells me the suit of the card, and it tells me the rank of the card. So if I pick up a 3 of spades, I can see that the suit would be a spade, and I can see that the rank would be a 3. So how can we get Python to represent this object? Well, we can create a card class. And this class will have attributes that tells us information about the suit and information about the rank. So we'll start by putting class and then labeling this class card. We can then put a colon, and the first thing we need to put is def, dunder init dunder, and we'll pass in self into parentheses. Now we know that when we hold a card, we really get 2 pieces of information. It's the suit and rank. So we're going to expect an instance of a card to have a suit, and we'll also pass in rank into parentheses. I can now define self.suit to equal suit, and I can define self.rank to equal rank. So up until this point, if I were to create an instance of a card, i.e. a single card, I would need to pass in a suit and a rank, and I could then call upon an instance of a card and access the suit and rank attributes accordingly to tell me information about it. Now to help us describe what the card is, it would be great if I could use the print statement on an instance of the card class so it tells me what the card is. For example, if I were to create an instance of the 7 of diamonds, if I were to print this instance, I would like to see 7 of diamonds printed to the screen. How do we do this? Well, we can utilize the dunder str dunder method. So if I were to put def dunder str dunder and then pass in self, I can then put a colon, and the sentence we want to see printed to the screen would therefore need to be return self.rank, i.e. the number on the face of the card, plus we can have a string with a space, then the word of, then another space, and then we can concatenate the suit itself. So we can plus self.suit. And at this point, I'm quite happy with this card class. So let's now test it and see it in action. So if I were to create an instance of the card class and we label this variable 3_clubs, and we set this equal to a call on the card class, we know that the card class needs to have 2 arguments, one representing suit and one representing rank. So if I pass in clubs as the first argument and 3 as the second argument, when I now use the print statement and pass in the 3_clubs variable, you can see we print to the screen 3 of clubs. And if I were to create another 51 instances of every other card in a standard deck of playing cards, when I print that instance respectively, we would get that card printed to the screen. Okay, so we now have an object that represents a single card. So where next? Well, in a standard deck of playing cards, there are 52 playing cards. And if I were given a brand new deck of cards, it would come in a pack, there would be 52 cards inside, all representing a rank and a suit, and they're normally in order. So we see 2 of hearts, 3 of hearts, 4 of hearts, all the way to the ace of hearts. We then have all the clubs, all the spades, and all the diamonds in order, which isn't very good for a card game because we then need to shuffle the deck accordingly. So there are a few things that I've mentioned there. I've mentioned the fact that a deck needs multiple cards, and I've mentioned the fact that a deck needs to be shuffled, otherwise it wouldn't be a very fair game. And what else do we do with a deck? Well, we deal cards from a deck. So not only do we need to create a method that enables us to shuffle the deck, but we'll also need to create a method for a deck which enables us to deal a specific card. So for this, I'm now starting to think that a good idea would be to create a deck class that handles all of that deck logic. So I'll put class, then deck, we can put a colon, and the first thing I'm going to do is put def, dunder, init, dunder, and then pass in self. We can then put a colon, and to start with, I'm going to need to think of a data structure that can store this deck information. So in my mind, the first thing I can think of is a list, so I'm going to set self.deck to equal an empty list. And this doesn't need to be passed into the parameters because we don't want a user to pass in anything that represents a deck. We are going to create an attribute called deck and set this equal to an empty string every time someone creates an instance of the deck class. What I can then do is append things to this list. And above in the global variable section, we created suits and we created ranks. So what I can do is loop through these variables and then append the respective card to the deck. So I can put for suit in suits, then a colon. What I then want to have is a nested for loop, which then loops over each rank of card. So I can then put for rank in ranks and then a colon. And what we can then do is just append these cards accordingly. So we can put self.deck, which accesses that empty list. We can then utilize the append method, so we can put .append. And in the append method's parentheses, what do we want to put here? Well, let's think about it. We want to put an individual card. And we've just created a card object that handles an individual card's attributes. So I can now pass in card objects to this append statement, which will then add them accordingly. For example, the 3 of clubs that we've tested above, the instance was set equal to a call on the card class, and then we pass in the suit and the rank. So in the append method, I want to call upon the card class, and in parentheses, I want to pass in the suit, which will come from the for suit in suits part of our for loop. And the second item we want to pass into our card class is rank, which comes from that nested for loop. So we build our card objects utilizing that card class by looping over the suit and ranks accordingly, and then we append them to our self.deck list. So every time we create an instance of the deck class, this will run and we'll get a full deck of cards. Now what would be quite nice is if we were to print what's stored in each instance of the deck class, we can then see what cards the deck has in it. So similar to what we did in the card class, we'll put def, dunder str, dunder, and then pass in self. We can then put a colon, and we'll first of all create a variable called deck_check, which will simply be set to an empty string to begin with. We can then loop over each element in self.deck with each element representing a card, so we can put for card in self.deck, then put a colon. Well, what do we want to do? Well, we just want to expand on that empty string that we've created above. So we can start with deck_check. We can then add a new line, so we can put plus equals, and then in single quotes we can put \n with a space, which is a way of us being able to create a new line in the print statement. We can then put plus, and what do we want to initially plus to this empty string? Well, we want to put card, which is each element in self.deck, which we know is an object of the card class, so we can put card, then put dot. We know that our card class has a dunder str dunder method which prints out the value of the card, so we can then put dot and then access the dunder str dunder method. We can then put parentheses, and what we want to return when we print out the instance of the deck class is a simple statement that states the deck you are using has, then a colon, and what we can then append to this string is deck_check. check, which will then print out our entire deck that's stored in self.deck. Okay, so let's now run this deck class and create a test deck accordingly. So let's create an instance of a deck class which we'll label test_deck, and we'll set this equal to a call on the deck class, which we know doesn't accept any arguments into its parentheses. With test_deck now set to an instance of the deck class, we can print what's stored in test_deck. When I do this, you can see that we print to the screen, the deck you are using has, and it then states 2 of diamonds, 3 of diamonds, 4 of diamonds, all the way through until the ace of diamonds. It then does the same for hearts, then clubs, then spades. So we have a full deck of cards here in an unshuffled order, but we do have 52 playing cards that are represented in this test_deck variable. Now, as mentioned, we need to be able to shuffle the deck and also deal a card from the deck, so we need to create 2 functions in this class that will then be methods that we can call to shuffle and deal a card respectively. So we'll first of all create our shuffle method. So in our deck class we can put def and we'll call the method shuffle. We can then pass in self to parentheses, and then I can put a colon. Now we know that the deck itself is stored in self.deck, which is that list we created in our init constructor method at the start. And what can we call in order to jumble up this list accordingly? Well, we can actually use functionality from the random module, and the method we want to call is shuffle, in which we will pass self.deck. So seeing as we want to use functionality from the random module, we can go back up to imports and then import random, because we now want to use functionality from this library. We have to now run this code cell, and if I go down, in the main body of the shuffle method, we can call upon the random module, we can place a dot, I can then call upon the shuffle method, in which we will pass in that list stored in self.deck, and that will then shuffle the cards accordingly. So let's now just check to see if our shuffle method works. So we'll rerun this deck class, we'll rerun the creation of our test_deck, and I'll now have a method I can call on test_deck, so I can put test_deck dot, then if I press tab you can see that one of the options is shuffle. If I put shuffle then parentheses, when I print what's now stored in test_deck, you can see that we no longer have 2 of diamonds, 3 of diamonds in order, then hearts, clubs and spades. You can see that our cards are now mixed up. It's a shuffled deck of cards. We don't know what order it's in, so the game that we now play with this shuffled deck of cards is going to be a lot fairer. Great, so the shuffle method works. Now let's just create a method that enables us to deal one of the cards from this deck. So we'll go back up to our deck class, and we'll define a method called deal. So we'll put def, then deal, and in parentheses we'll pass in self. Now what do we want to obtain from this deck of cards? Well, seeing as the deck of cards is stored in a list, and we want to obtain a single card from this list, well, I'll define a variable called single_card, and I'll simply set this equal to the list itself, so self.deck, and then I'm just going to utilize the pop method, which will then pop a card from the end of the list. I can then return the variable single_card. So if I were to call upon the deal method, we would expect to get a single card from the list of values stored in our self.deck list. Now we'll see this in action shortly, but up until now we've created 2 classes, one representing a single card, one representing an entire deck of cards. We have the ability to shuffle that deck, and we have the ability to deal a single element, i.e. card, from that deck. So this logic could actually be used in any card game as of now, so far so good. In the next video, we'll move on to creating more classes which represent the treatment of a hand of cards, i.e. the cards that the player and the dealer have on each round of the card game. So I'll see you in the next video. Okay, so continuing on from the last video, we're now going to create a data structure that enables us to deal with individual hands that either the player or the dealer has. So let's just think for a second what an individual hand looks like in terms of attributes and methods, i.e. what we would expect to be able to do with a hand. Well, to start with, when a player decides to play, they will have no cards in their hand. And when we create an instance of a hand, we know that we're going to be interested in a few things. We're going to be interested in the cards that they've been dealt, and we're going to be interested in the value that these cards sum up to, because that's the whole idea of the game 21. Now we're also going to be interested in how many aces that hand has, because if a player does have an ace, well, we know it can represent either 11 or the value 1, and we're going to have to address this in our logic. Now what else do we need a hand class to be able to do? Well, we need to be able to add cards to our hand. So for example, if I had 2 cards that sum up to 6, well, I'm likely going to hit at this point and obtain another card from the deck in order to get closer to 21. So I'm going to want to create a method that enables me to add a card to the instance of the hand class. And finally, our hand class will need to deal with that situation where an ace value is reduced from 11 to 1. Because when I'm looking at the hand, depending on the hand's value, I will want the ace to represent 1 if the value goes beyond 21, or I want the value to be 11 if the cards themselves sum very close to 21. So we'll also deal with the adjustment for aces in this data structure. So we'll create a class called hand, and the first thing we do, well, we put the keyword def, we then put dunder, init, dunder, and then pass in self into parentheses, and then we put a colon. Now when we create an instance of a hand, we need a few things to be set up from the start. We need to create a data structure that stores the cards for that individual hand. So I can create an attribute by putting self.cards, and I can set this equal to an empty list, just like we did when we created the deck initially. Now at the start the hand is empty, so we can initially set an attribute called value, so we can put self.value, and we'll set the value for these cards to be 0 to begin with. And obviously when you're sitting there with no cards, you obviously have no aces, but we do want to keep a track of them, so we'll create an attribute by putting self.aces, and we'll set this equal to 0. So we now have an attribute that tells us how many aces we have in our hand. Okay, so that's a good start, but this hand would never have any cards in it if we just left it like this. So we need to create a method that enables us to add cards to an individual hand. So we can create a method called add_card, and in parentheses we'll pass in self. We can then put a colon, and what do we want this add card method to do? Well, we want it to add cards to that self.cards empty list of the hand. So I can put self.cards, I can then access the append method, and in parentheses we're going to need to pass in a card. So I can put card in brackets, but seeing as we haven't passed in what card we want to add to our cards list, we'll also have to have it so that our add_card method accepts an argument into a parameter labeled card. And our expectation here would be that it passes in a card object from the deck. Now once we've been given a card, we know that this card would have a value, so we then need to adjust our self.value attribute by putting self.value then plus equals, and what do we want to add here? Well, we want to access that dictionary which we created in the global variables section called values, because we need to obtain an integer associated with the rank. How do we access a specific element from a dictionary? Well, we can then put square brackets, and then we need to pass in a rank associated with the card that we've been dealt. Now, seeing as our expectation would be that a user passes in a card object at this point, well, we know that the card objects have an attribute called rank, so inside the square brackets we can put card.rank. And this would then pass in the face value of the card. That value would then get looked up in the keys within the values dictionary, and would then add the value to self.value that we created above. So that should deal with the logic of adding a card to the hand. So let's leave it like this for the time being. So we'll now run our hand class and we'll test to see if it works accordingly. So the first thing we'll do is create a test deck, so we can put test_deck and we'll set this equal to a call on the deck class. We then want to call on test_deck.shuffle because we want our deck to be shuffled to make the game fair. I will then print the test deck just to check that it's been shuffled accordingly. And I now want to create a test player. Now this could be the player or it could be a dealer, there could be 20 players, but we'll create a single instance of a player by putting test_player, and we can set this equal to a call on the hand class because each player will be dealt a hand. What we can then do is put test_player, and we know if we put dot, we're going to have access to a method called add_card. So I can call upon add_card, and in parentheses, it's expecting us to pass in an argument that represents a card object. And how do we do this? Well, we know to get a single card from the shuffled deck, we can now call upon test_deck, and if I scroll up to jog your memory, you can see here we created a deal method in our deck class. So I can put test_deck, and if I put .deal, we know that we're going to be dealt a single card from the deck itself. So if I do this once, we're going to get a single card. If I copy and paste this underneath, we know at this point we're going to be dealt a second card. And if I then call upon the value attribute of the instance test_player, so test_player.value, when I run this code cell, the first thing I can see is the shuffled deck of cards, and the next thing I can see is the value associated with the two cards that I've been dealt. In this case, it's 18. And just to double check that the two cards that I do have in my hand do indeed add up to 18, I can check by putting for_card in test_player.cards, then put a colon. I can then print card. When I run this, you can see that we have the cards King of Hearts and the 8 of Hearts. And when summed, they do indeed add to 18. The King has a value of 10 and the 8 has a value of 8. Now at this point, we've created an instance attribute called aces, but we haven't done anything with it. So if one of these cards was indeed an ace, well, we wouldn't have tracked it and therefore couldn't determine whether we wanted the value of the ace to be 1 or 11. It would be defaulted to 11 based on the dictionary that we set above. So let's now address the case when we get dealt aces. So the first thing we're going to do is amend our add_card method that we've defined in the hand class. And all we want to do is check to see if the card is an ace. If it is, we will increment the aces attribute that we defined above. So within the add card function that we've defined in the hand class, we can put if card.rank. So if the card's rank equals ace, then we can put a colon, and what we then want to do is put self.aces plus equals 1 to increment the count of aces by 1 for our respective hand. Now at this point, we are tracking to see how many aces we have in our hand every time we're dealt a card, but we wouldn't have adjusted the value from 11 to 1 if our value exceeds 21. So we're going to need to define a function within our hand class in order to adjust the value attribute when we want the ace value to be 1. So we can put def, and we'll call this method adjust_for_ace. We can then put parentheses, and in parentheses we'll pass in self. We can then put a colon. Now let's think about the logic we need to implement. There will be two things we need to check. We firstly want to check to see if we have any aces in our hand, and the second thing we'll want to check is to see if the value is greater than 21. If both of these conditions are true, well, we're going to want the value to be reduced by 10. In other words, take us from a value of 11 to a value of 1. So I can start by putting while self.value is greater than 21. and self.aces. And if the aces attribute is 1 or more, well then the Boolean expression will come back as true. If it is 0, it will come back as false, so we can leave it as and self.aces. If you wanted to, you could put self.aces is greater than 0. I can then put a colon, and we then want to adjust our value attribute by 10. So we can put self.value minus equals 10. So at this point, we've reduced the value by 10, but can you think what else we would need to do? Let me give you a clue. Imagine we had been dealt 2 aces. Well, if we'd been dealt 2 aces, the value of the 2 aces would be 21. So we only want one of the aces at that point in time to be worth 1. So what we'd need to do is decrease the value that is stored in aces by 1. So I would also need to put self.aces minus equals 1. And now let's go through the scenario. Suppose we were dealt 2 aces. Well, self.value is greater than 21 because it's 22. And self.aces does have a number greater than 0. So that also evaluates to true. Well, then self.value will be reduced by 10, so we go from 22 to 12, and then self.aces is then decreased by 1 because we've only reduced the value of 1 ace by 10. It now goes back up to check in the while loop. While self.value is greater than 21 would then be checked again. At this point it's worth 12, so that evaluates to false. We have 1 ace that's worth 1, and we have 1 ace that's worth 11. So this should deal with the logic when we want to adjust the value of an ace if we go beyond 21. So try testing this hand class numerous times, see what cards you get back, see what the values are, to make sure that the logic is working as expected. Realistically, you'd only be able to test the ace logic if you were dealt 2 aces during the testing. So we may need to wait till later on in our code when we start adding more cards to our hand in order to see if it works accordingly. In the next video, we're going to address the logic to start dealing with our chip count and enable players to make a bet in the game. So I'll see you in the next video. In this video, we're going to address the problem of tracking a player's chip count and then allow a player to place a bet in the game. So in order to do this, I'm thinking it would be a good idea to create some form of chip account that will allow us to track the player's chip count from the start, and then have some methods that add chips to the account if the player wins the round or deducts chips from the account if the player loses the round. And just by saying this out loud, I have already mentioned some methods and attributes that would work well with this type of problem. So my mind has gone straight to setting up a class to deal with a chip account. So let's dive straight into creating this. So I'll start by creating a class called chip account, and I can then put a colon. I will then put def dunder init dunder, and then in parentheses I'll pass in self and will then put a colon. Now to start with, I'm going to keep this simple. Let's suppose that everybody who starts the game will start with a default amount of chips, and we're going to start that chip count at 100. So I'm going to set an attribute called total, so I can put self.total, and I'm going to set this equal to 100. Now I could make this more dynamic by letting a user stipulate how many chips they want to start with, but for simplicity, we'll default this to a numeric literal. So with a player starting with 100 chips, we know they're going to want to bet a certain amount of these chips. So we're going to need to also set an attribute called self.bet, but because we don't know what this bet amount is just yet, and they haven't actually made a bet, we're going to default this to the value 0 to begin with. So we have 2 instance attributes, one labelled total and one labelled bet. Now what else do we expect to happen to our chip account? Well, we expect it to grow in number if a player wins the bet, and we expect it to decrease in number if a player loses a bet. So we'll define a method called win_bet. We'll pass in self into parentheses and then a colon, And all we're going to do is increment our total attribute by the amount of the bet attribute. So we're going to put self.total, then put plus equals, then self.bet. So when win_bet is called, the total will be incremented by the amount that's passed into self.bet. We'll then copy and paste this method and we'll label the second method lose_bet. We can then change the plus equals to simply be minus equals. And this will decrease the amount of chips stored in the total attribute by the amount that's passed into self.bet. So this class is storing the total amount of chips they have. It's also allowing us to set a bet amount. It's incrementing the total chips if a player wins the bet, and it's decreasing the amount of chips stored in total if they lose the bet. And I think this will do for our chip account. So if we wanted to create an instance of this chip account, we could put something like player_chips equals a call on the chip account class. And to check that it's storing the correct information from the start, if I put player_chips and then a dot, when I press tab, you can see that we can access the bet attribute, we can call upon lose bet, we can see total, and we can also call upon win bet. And if I select total and then run this code cell, you can see that we get the value 100 returned. So that's good for the time being, but we haven't yet created a function that allows us to take bets in the game. We can store the information, but we haven't allowed a user to actually specify the bet that they want to place. So let's do this now. So we're going to create a function called take_bet, and this function is going to take in one argument, and it's going to relate to an instance of the chip account class that we set up for an individual player. So for naming convention, we'll simply call this chips for the time being, but we expect an instance of the chip account to be passed in to this parameter. We can then put a colon. Now let's think about how we want to collect the bet information. Now my first thought is the bet should be an integer. If they put the word 5 or they pass in another data type, we're not going to be able to use this efficiently. So it needs to be an integer. So in order to add some control in our code, we're going to first of all have a try block, and inside this try block, we're going to set chips.bet. And we know we have an attribute called bet on this chips object because we expect an instance of the chip account to be passed in to this function. So we're going to set chips.bet to equal a call on the input function, for which we're then going to ask a user to place your bet, ! We're also then going to ask how many chips, and we want to convert this input into an integer. So we can wrap this line of code in the built-in int function. Now, if the input that a player puts in cannot be converted into an integer, we know that we'll run into a value error. So we can then put after our try block an except statement that states except value error, then a colon. We then want to print a message to the user that states you must enter an integer. So if they don't pass in an integer, they're going to get this message accordingly. Now when they get this message, we're obviously going to need to ask them again how many chips they would like to bet. But we've already got a try block above, so how do we get this block of code to run again? Well, we're going to need to loop over this code in order to rerun the try block. So we can place our try and except statements so far into a while loop. So we'll proceed this code with while true, then a colon, and then we can make sure our indentation for our try and except blocks are inside the while statement. Now, because we've set a while true statement, we know the only way we can break out of this statement is if a player puts in an integer as per expectation. However, there's one more check we need to make sure the bet is acceptable. We have to make sure the player has enough chips in their account in order to make the bet. Now, we know that the total amount of chips that a player starts with is 100, but if a player bets 120, we would expect a message to print to the screen stating that they don't have enough chips. So we also need to have an else statement after our except block, which will run if an integer is passed in, but we want to do that final conditional statement. So we can put else, then a colon, and now we can check to see if they have enough chips. So we can put if chips.bet is greater than chips.total, which we know defaults to 100 at the start. We can then put a colon. We'll then print the message, you don't have enough chips, full stop. You only have, we can then put a comma, and we'll then concatenate chips.total to remind the user how many chips they have in their account. Now, if they do have enough chips to make the bet, that's great. We want to store this in chips.bet so we can then break out of this while loop because the necessary information has been passed in and has also been validated. So after the if statement, we can put else, colon, then we can put the keyword break. And that should do it for our function to take bets in the game. So let's now test our function. We have already set an instance of the chip account class called player_chips. So if I call upon the take_bet function and in parentheses pass in that instance called player_chips, when I run this code cell, you can see the first thing that we're asked is place your bet. How many chips? Now, knowing that we've put some validations in place, I want to see if it addresses a string input accordingly. So let's suppose I type in the string 5. When I press return, you can see that we get the message, you must enter an integer. And then we're asked again, place your bet, how many chips? So great, it's dealt with this string input, but does it deal with the bet where we place more chips than we have in our account? Well, let's test. If I now put in the integer 120 and then press return, you can see that we print you don't have enough chips, you only have 100. So fantastic, this is now working accordingly, and if we ever place a bet larger than the amount of chips we have in our account, we're going to be asked to place another bet. So let's now place a bet which is an integer and is also less than the total of 100, so if I place a bet of 30, when I press return you can see that we're no longer asked to place a bet, and if I take a look to see what's stored in player_chips.bet, so accessing the bet attribute, you can see that it currently stores 30, and we would then expect this to be added or subtracted from our total account depending on whether the player wins or loses, and obviously that would mean we'd need to call upon the win bet or lose bet methods that we created in our chip account class at the start of the video. In the next video, we're going to move on to creating functions that allow us to add another card to our hand and also deal with the functions for the game outcomes. So if a player wins, we want their chip account to be increased accordingly. If the player loses, we want it to be decreased accordingly. And we could also end up with a situation where the game is tied, where both the dealer and the player has the same amount in their hand. So we'll need to address this also. So I'll see you in the next video. In this video, we're going to implement the rest of the logic we need for our card game 21 that deals with when a player hits or when they stand. We want to be able to show the player's cards and we want to show the dealer's cards. And remember, we only want to show one dealer's card when playing, so we're not given too much information, which makes the game easy. And we also want to deal with the game outcomes. So what happens when a player busts, when the player wins, when the dealer busts, or when the dealer wins. And also don't forget, there could also be a tie in the game. Once we've completed this video, we'll be on to the last part where we need to implement the gameplay simply by calling upon our functions and our classes in an order that makes the game flow. So the first thing I want to do is deal with the situation when a player decides they want to hit. Now, if I scroll back up to where we defined our hand class, we defined two methods. We defined an add_card method, which will add a card to a player's hand, and we also adjusted for aces if a player gets dealt an ace and the value of their cards exceeds 21. So every time a player hits, we're going to need to deal another card from the deck, and we also created that deal method in the deck class, and we're going to want to add that card to the hand of the player. So we need to utilize a couple of class objects here in our hit function in order to make this work. So we'll define a function called hit, and in parentheses we're going to create two parameters. One is going to be an instance of the deck object, so we can pass in a parameter named deck to start, and the second object we're going to need to pass into this function is an instance of the hand class, where we can then add a card to the hand. So we can put hand as our second parameter. We can then put a colon. Now, if we decide to hit in a game of 21, we would essentially be dealt another card, and that card will be added to our hand. So we can call upon hand and then place a dot, and we then want to call upon the method add_card. We can then put parentheses. Now, if I once again scroll back up to where we've defined add_card, you can see that this method accepts one argument labeled card, and this will be a card object. The reason we know we want this to be a card object is because we're also trying to access the attribute rank from this card object. So what card object do we want to pass in to add_card? Well, we want to pass in a dealt card from the deck. So let's remind ourselves what this looks like. If I scroll up to the deck class, you can see at the bottom here we've defined the deal method, where we pop a card from self.deck and then return it, and we know that the objects that are stored in self.deck are an instance of the card class because we append them one by one from our for loop and nested for loop here within our init constructor method. So when we call upon the function hit, we want the add_card method to add a card from the deck, so we can call deck.deal and then put parentheses. Now we also want to adjust for the aces in case the card's value in the hand is greater than 21, and we do have an ace. So we can also, after this line of code, put hand.adjust_for_ace and then parentheses. So we've now created a hit function in case a player ever asks to hit. But we now need to create a function that asks the player whether they want to hit or not, because a player may be happy with the value of their cards and want to stick. So we're going to create a method called hit_or_stand, and in parentheses we're going to want to pass in two pieces of information. We're going to want to pass in the deck object in case a user wants to hit, and obviously this needs access to the deck class object. And the second parameter we want to pass in is an instance of a hand that's been created for a given player. So we'll also pass in hand, and then we can put a colon. Now a player will only hit or stand if the game is running. And the way I intend to showcase that a game is running is by creating a variable called playing and setting this equal to true. But if a player decides to stand because they're happy with their cards, I'm going to need to convert playing to false in order to transfer the game to the dealer. So I'm going to foresee the need to create a playing variable which will set to true, which I'll need to also access, so I can start by putting the global keyword, which will then be able to access this variable, and then I can put playing. So it will essentially allow us to control an upcoming while loop later when we implement the gameplay. We can then create our hit or stand logic, so we're going to create a while loop so we can put while true, and therefore this code will continue to run until we break out of this while loop. And how do we want this while loop to work? Well, we want to keep asking a simple question to the player whether they'd like to hit or stand. Only up until the point where they stipulate they want to stand will we break out of this while loop. So we'll create a variable called x which will accept some input, so we'll put input and we'll ask the question, would you like to hit or stand? ? Enter H or S. Then a colon. So this gives the user some guidance as to what we're expecting to be put into this input. We can then put some conditional statements. So we can put if x, which then accesses the string that's stored in the variable labeled x, and we can then access the first letter, so we'll put 0. We can then put dot lower to convert this to lowercase in case a user decides to put this in uppercase for some reason. We can check to see if this equals the lowercase h, and if it does, we know the player wants to hit. So what do we then want to call upon? Well, we want to call upon the function we defined above, So we can call upon the function hit, and this has two parameters in which we need to pass in arguments to. So we can first of all pass in deck, and the second argument we'll pass in will be hand. We can then have a second conditional statement that states elif x square brackets 0 dot lower with parentheses equals the lowercase s. Well, this means that the player has decided to stand because they're happy with the value that their cards add up to. So we can put a colon, we'll simply print player stands, full stop, and we can then stipulate that the dealer is playing. We will then set the playing variable, which we're going to create below for our while loop. We will set playing to equal false, which will enable us to break out of a while loop that controls the player's turn. Now, if the input is not H or it's not S, we will simply have an else statement that prints, sorry, please try again. We can then put the keyword continue, which will take us back up to the start of the while loop, where the player will be asked for input. After these conditional statements, we will simply break out of this while loop, which will deal with an instance where a player hits or stands. Okay, so that should do for the hit or stand logic. We'll now deal with the problem where we want to show cards to the screen. So we're going to define two functions here, one during the gameplay where we only show one card for the dealer, and then one at the end of the game where we show every card that the player and dealer has so we can see how the round played out. So we'll create a function called show_partial_cards, and this will have two parameters that we pass in arguments to. We're going to have an instance of the hand class, which we'll define as a player, and we're also going to have a dealer's hand class, so we'll call this dealer. And this will enable us to access the cards in the respective player's hands. We can then put a colon, and we simply now need to present the information to the screen. So we'll first of all print a string, which is a new line, and we'll say dealer's hand with a colon. We'll then print the first card, and as we know, we want this to be hidden, so we'll simply print a space, then 3 asterisks, then a space, so this will represent the dealer's hidden card, and we'll then print an empty string, we'll put a comma, and we'll then access the dealer's hand, so dealer dot cards, and then access index 1, which we know will be their second card in their hand. We can then print the player's hand, so we'll print a new line, put player's hand, then a colon. Now we could use the same syntax like we did with the dealer, where we access first of all card at index 0, then card at index 1, but let me show you some cleaner syntax that can be used. We can put a comma, then we can put star, and then access the player's hand. We can then access the card's attributes. We can put a comma, we'll put the sep equals a new line, and what this will do is simply access each element from the player's hand and print them to the screen, with both cards being presented on a new line. Okay, so that deals with the partial cards. I will now copy and paste this function definition, and I'll call the second function show all underscore cards. So this is going to show every card of both players after the game has been completed. And what I want to present here is as follows. So the first thing I'm going to do is copy and paste the fourth line where we've stipulated the player's hand. I can copy this line and I'll paste this over the first line in the function, and we'll convert the player's hand to state dealer's hand, and we'll then access dealer.cards rather than player.cards. So this will then print out all of the dealer's cards. We can also print out what the dealer's cards add up to. So instead of printing out some asterisks, what I will print out is dealer's hand equals, I can then put a comma. We know that the hand class has an attribute called value, so I can access dealer.value. I can copy and paste this code line. I will delete where we've accessed dealer card 1, and I'll paste this as the fourth line of code, and we'll simply state player's hand equals, and we can then access player.value to access the value of the player's hand. So a couple of functions here that enable us to access values from the hand class and then present them to the screen so we can see who's won accordingly. Now observing who's won with our eyes would be okay, but we want the computer to be able to work out who's won, because we'll also then want to adjust the chip account depending on whether the player has won or lost. And there are 5 game outcomes that I can think of that we need to address. We need to address the situation where a player busts, i.e. their value goes beyond 21. We need to address the situation where a player wins because they're closer to 21 than the dealer. We have the same 2 scenarios, but the dealer busts and the dealer wins. And the 5th outcome is where the game is tied. So let's now create functions that deals with each of these scenarios. We've already created the attributes and the objects that we need in order to determine the game outcomes, so we simply need to pass these into the respective functions. So we'll first of all create a function called player_busts. We want to pass in the player's hand, we also want to pass in the dealer's hand, and we also want to pass in an instance of the player's chip account. We can then put a colon. We'll first of all start by putting print, and then we'll put the string player busts. And what happens if the player busts? Well, we want to access the instance of the player's chip account, so we can put chips, and we've already defined a function in there that deals with a lost bet, so we can access the lose_bet method, which will then decrease their chips by the amount that they've bet. I can copy and paste this function, and I can change the function's name to be player_wins. I can change the print statement to state player wins, and rather than calling upon the lose_bet method, I can call upon the win_bet method. Now I can copy and paste these 2 functions, and we'll then convert player_busts to dealer_busts. And what happens if the dealer busts? Well, we want to call upon the win_bet method on the player's chip account because they've won the bet. And then we'll convert the player_wins to dealer_wins. And what happens if the dealer wins? Well, we want to call upon the lose_bet for the player's chip account. We then have the final scenario, which would be if the dealer and player tie in the game. So we can create a function called tie, and in parentheses we'll pass in the instance of the player's hand, and we'll pass in the instance of the dealer's hand. Now the reason I'm doing this is because I'll utilize these parameters later when we implement our gameplay, but what I'll do for the time being in this function is simply print to the screen dealer and player tie! Now up until this point, let's just recap what we've done. We've set some global variables for suits, ranks and values. We've created a card class which deals with the suit and rank. We've created a deck class that enables us to store a complete deck of cards, but also enables us to shuffle and deal a card from the deck. We've created a hand class that enables us to create a hand for different players, including the player and the dealer. We've then created the ability to create a chip account for a player, which deals with a won bet and a lost bet. We're allowing each round to take a bet from a player. We've dealt with the scenario where a player hits, where a player stands, and we're also showing the cards that both the dealer and the player have at any point in time. We've also dealt with the 5 different game outcomes, which will then adjust the chip account accordingly. In the next and final video, we're going to implement the gameplay utilizing the functions and classes that we've created above to create a fully working game of 21. So I'll see you in the next video. In this 5th and final solution video to the Las Vegas casino project, we're going to implement the gameplay. So let's work through each stage step by step, calling upon our class objects and our functions that we've defined above in order to get a working solution. Now the first thing I'm going to do is just set an instance of the chip account class. And like we've seen earlier, this will just create an object that allows us to see how many chips a player has, and will also enable us to deal with a bet that's won and a bet that's lost. So we'll start by putting player_chips, and we'll set this equal to a call on the chip account class. Now remember, this will default the amount of chips that a player has to 100. But feel free to change the class so that it asks a player how many chips they'd like to start with. Now, like we've seen in other projects and other games that we've implemented, we're going to start our game logic by creating a while loop. So we'll start with while true, then we'll put a colon, and this will mean that this game will continue playing until we break out of this while loop using the break keyword. Now the first thing I want to do when we run this game is print an opening statement to the screen so that it gives the user a little bit of information about the game. So we're going to print a statement to the screen using triple quotes, and the statement will read, "Welcome to 21. The aim of the game is to get as close to 21 as you can without going over!" Exclamation mark. The dealer will keep hitting until they reach 17. We can then state that aces count as 1 or 11 to let the player know how aces are treated. Okay, so that will do for the opening statement. Now what is the first thing we need to play 21? Well, we need a deck of cards. So the next thing I'm going to do within this while loop is set a variable labeled deck to equal a call on the deck class that we created above. Now that's not the only thing we need to do with this deck, because we also want to shuffle it so that the cards are in a random order. So the next thing we'll do is access the shuffle method that we created within the deck class, so we can put deck.shuffle with parentheses, which will then shuffle the deck upon each iteration of this while loop. The next thing we need to do is create two players. We want the player's hand and we also want the dealer's hand. So we'll start by creating a variable called player_hand, and we'll set this equal to a call on the hand class. We can then add two cards to the initial hand of the player by calling player_hand.add_card, and we know that we want a card to be dealt from the deck, which has a method called deal, so in parentheses we can pass in deck.deal, which will then pop a card object off of the cards attribute that's set in the deck class, and because we've shuffled the deck, we won't know what this card is as of now. We can then copy and paste this once more so that the player's hand has two cards dealt from the deck. We can then copy these 3 lines of code and paste them underneath, and then we can change player_hand to read dealer_hand for each of the 3 code lines. This will then create the dealer's hand and will then deal the dealer 2 random cards from the deck. So we've welcomed the player, we've created a deck, we've shuffled the deck, and we've dealt the hands to the player and the dealer. The next thing we want to do is take in the bet from the player. So we can call upon the function that we created called take_bet, and inside parentheses we'll pass in the instance of the chip account class that we created above, for which we labeled player_chips. So when we get to this part of the while loop, it will ask the player how many chips they'd like to bet. Now once the player has made their bet, we want to show the cards to the screen. Now remember, we want to show what the player's cards are so they can see whether they want to hit or stand, but we don't want to show all of the dealer's cards to begin with. And we created a function that deals with this logic called show_partial_cards. So we'll call upon the show_partial_cards function, and in parentheses we simply need to pass in the player's hand, so we can put player_hand, and we also need to pass in a second argument for the dealer's hand, so we can also pass in dealer_hand that we created above. Now this will keep one of the dealer's cards hidden based on the logic that we created above. So these are the steps that we'd want to go through for every round of 21 that's played. But we also now need to create a nested while loop in order to deal with the hit and stand logic. So the first thing that's going to be asked is whether the player is going to hit or stand. And we want this while loop to continue until the player stands, and therefore we break out of this while loop. And to remind you how I implemented this in the hit or stand function, you can see that if I scroll to the hit or stand function, you can see we've implemented this by controlling this while loop by creating a variable called playing, which we haven't yet set. If the variable playing is set to true, then we will continue asking the player if they want to hit or stand. But as soon as they enter S, i.e. they stand, you can see here that we set the playing variable to false. So to start with, the game needs to have set this playing variable to equal true. So at the very top, just above where we've defined player_chips, I'm going to set a variable called playing to equal true. Now we have this set, I can now put a nested while loop that says while playing, which in other words reads while true, we can then ask the player whether they want to hit or stand. So we can now call upon our hit_or_stand function, and this function takes in two arguments, one representing the deck object that we've created above, so we can pass in deck. We can then put a comma, and we can then pass in the player's hand, so we can put player_hand as the second argument. Now once we've gone through this function for the player, we then want to show the partial cards again. So if the player hits, we want to be able to see what that third card is. So we'll once again call upon show_partial_cards and pass in the player's hand and also pass in the dealer's hand. So at this point, a player will be able to see what their cards add up to, whether that be 3 cards or 4 cards, however many times they've hit, in order to ascertain whether they want to stick or hit on the next decision. Now, there could be the scenario where a player hits and the value exceeds 21, and we haven't dealt with this scenario yet. So in this nested while loop, we're going to have a conditional statement that checks to see if the player's hand value is greater than 21. So if we put if player_hand dot value is greater than 21, well, at this point, we know the player busts. And we've dealt with this scenario in a function defined above. So we can then call upon our function player_busts, and we can pass in the arguments that this function is expecting. And we know this is player_hand, we know that the second argument is dealer_hand, and we know the third represents the instance of the chip account that we've set up for the player, so we can also pass in player_chips. And at this point, if a player has bust, then we can break out of this nested while loop and then continue the outer while loop that we've created above. So let's now continue with the rest of the logic outside of this nested while loop. Now, if the player's value wasn't greater than 21, but the player entered S, i.e. they stuck with the cards that they had in their hand, well then we need to deal with this outcome. And there could be a couple of outcomes. The player's hand may have a value less than 21, but so may the dealer's. But which hand is closer to 21 and which player therefore ends up winning? Well, let's deal with that scenario now. So we're going to create another conditional statement that states if player_hand dot value is less than or equal to 21, we can then put a colon. We can now deal with these scenarios one by one. Now, if the player's hand is less than 21, well then we want to play out the dealer's hand until their cards are greater than 17, just like the gameplay instructions stipulated. So let's deal with this accordingly. We can then put while dealer_hand dot value is less than 17, well we just want to add a card to the dealer's hand. So we can call upon the hit function that we created above, so we can put hit, and in parentheses we can simply pass in the deck that it's expecting, then a comma, then we can put dealer_hand. Because it's the dealer hand that we want to add these cards to. So at this point, we know the player's hand's value is less than or equal to 21, and we know that the dealer's hand's value is definitely not less than 17 because we would have broken out of the while loop at this point. But we don't know whether the dealer's hand is less than or equal to 21, or the dealer's hand exceeds 21. So let's now present this information to the screen in order to see who's won the game. So the next thing we can do within this if statement is show all the cards from the dealer's hand and all the cards from the player's hand. And we created a function that dealt with this above. So we can call upon show_all_cards and then pass in the player's hand, comma, and then the dealer's hand. And then we need to simply run through the different winning scenarios. So we can put if the dealer_hand dot value is greater than 21, well at this point we know that the dealer would have bust, and therefore we can call upon dealer_busts and pass in the player's hand, the dealer's hand, and the player's chips, and this will therefore add on the bet value to the total amount of chips that the player has in their account. We can then copy and paste these code lines, and we can change if to be elif, so the next conditional statement, elif the dealer hand.value is greater than the player underscore hand.value. Well, at this point, the dealer hand is closer to 21 than the player's hand. So we can then simply call upon the function dealer underscore wins, which has the same arguments passed into it as the dealer underscore busts function. So this then deals with a scenario where the dealer wins. If we copy and paste these two code lines, we can then check to see if the dealer hand.value is less than the player hand.value. Well, then we want to call upon the player underscore wins function. And this has the same arguments passed into it as the dealer underscore wins function created above. So this therefore deals with the four scenarios where the player busts, which we've defined here, where the dealer busts, defined here, where the dealer wins and the player wins. The final thing we need to do is address the scenario where they tie, so we can have an else statement that calls upon the tie function, and we know the tie function takes in two arguments, one relating to the player underscore hand and one relating to dealer underscore hand. Great, so outside of this if statement, we can now present some more information to the screen. So let's first of all tell the player what their total chip count is. So we can print a sentence that states a new line, and we can put players' winnings stand at, we can then put a comma, and we can then access player underscore chips dot total. So if they started with 100 and they bet 30, we would expect their total to be 130 if they won the round, or 70 if they lost the round. Now at this point, they may want to walk away from the game, but they might want to continue playing. And we want it so that their chip total would be 130 if they won the bet going into the next rounds. We don't want to reset their chip account to 100. So at this point, we'll simply set a variable called new underscore game, and we'll set this equal to a call on the input function where we ask, would you like to play another hand? Enter Y or N, then a colon. We can then put some simple logic that states if new underscore game access the first element of the string, so putting square brackets then 0, dot lower with parentheses equals the lowercase y, colon. We'll then set the playing variable to equal true, so the game would then start again. We will then put the keyword continue, which takes us back up to the top of the while loop, which will then welcome them to the game. It will create a new deck, shuffle it, create the hands, and so on. It will then go through the gameplay that we've just written, but the player may not want to play again. And if they don't, well then we can put else, then a colon, and we'll simply print thanks for playing. And we can then break out of the outer while loop that we've created, and the game stops. So I'm hoping up until this point, this will be the complete game logic that we require in order to get a working game. So let's see it in action. So if I go up to kernel and then click on restart and run all, we can then restart and run all cells. Well, we first of all get to the point where we're testing our take underscore bet function. So let's just put in any value here. We can put in 10. And if I didn't want that to run, I could simply comment out that code line. But then we get down to the main part of the game. You can see that we've got a welcome message to the screen, welcome to 21. The aim of the game is to get as close to 21 as you can without going over. The dealer will keep hitting until they reach 17. Aces count as 1 or 11. Place your bet, how many chips? Now I'm feeling quite confident with this first round, so off the 100 chip count that I know that I start with, I'm actually going to bet 80 of these chips. When I hit return, we can see that the dealer's hand starts with a hidden card that we can't see, but they have also been dealt the jack of spades, and we know this has a value of 10, and my hand starts with the queen of hearts and the 3 of hearts, so my value so far is 13. I know this is too far away from 21 to be able to win, especially if the dealer's hand is greater than 17, so I want to hit. So if I put in H and then press return, you can see that the dealer's hand stays as it is because we haven't finished our turn yet, and my hand is now the queen of hearts, 3 of hearts, and the 7 of hearts, When I add this up in my head, I get 20. I'm very happy with 20, so I'm going to stick on this round with the value 20. So if I put S, I can see that the hidden card for the dealer was actually a 7. It was the 7 of diamonds. The dealer's hand therefore added up to 17, which would then stop the dealer from hitting because they've now got a value greater or equal to 17. My hand was 20, therefore player wins. Players' winnings stand at 180. Fantastic. Would you like to play another hand? Yes, I would, so therefore I'll put Y. And we're then presented with the welcome message again, and place your bet, how many chips. Now for this next bet, I know I only have 180 chips in my account, but what happens if I try to bet 200 chips? Well, if I put 200 and press return, you can see that we get the message, you don't have enough chips. You only have 180, and that's exactly what we expect. So we're asked to place our bet again, how many chips? Let's go bold, let's make a 170 chip bet. So if I put 170 and press return, I can see that one of the dealer's cards is the 5 of hearts, and we've been dealt a 4 of clubs and the ace of clubs. Now remember, the ace of clubs could be a 1 or 11 depending on the hand's value, so I'm going to hit in this instance to see what I get as the next card. When I do this, I've got the 3 of diamonds that's been dealt to me, so I can either treat this as a value of 18 or I can treat this as a value of 8. Would you like to hit again? I'm feeling a little bold, so I want to see the 4th card. And when I do this, I'm presented with the 10 of hearts. Now at this point, if the ace was 11, I would be greater than 21 and the adjust for ace function would be called into play. So our value at this point is 18. Now I think I'd be very lucky to get a 1, 2 or 3, so I'm going to stick at this point and hope that the dealer doesn't get the value 19, 20 or 21. So let's put S and then return. So if I take a look at the dealer's hand, I can see that the dealer started with the Jack of clubs and 5 of hearts, which meant they had a value of 15. They therefore hit and the dealer's hand ended up at 25. I ended up with 18, the dealer therefore unfortunately bust, and the player's winnings now stand at 350. Fantastic. We started with 100, we went big and got 350. Would you like to play another hand, Y or N? I'm going to put in N, and we then get the message, thanks for playing. So we've now created a fully functioning game of 21, which enabled us to tackle many different problem statements along the way. We've created cards, we created hands, we've dealt with chips and allowed the player to make bets in the game, we dealt with the different game outcomes, and I think the Las Vegas Casino would be very happy with this version of the online game. Now when you revisit this solution or go through it step by step, make sure you understand what each code line is trying to do. If you're able to get to the point where you understand what each code line is doing, that's fantastic. You're definitely on your way to utilizing Python's object-oriented programming capabilities to create some really sound solutions. Obviously, we've utilized it to address a card game of 21, but you can utilize Python to address anything that you want. The opportunities are endless, so continue your learning down this path to really get the most out of the language. Now in subsequent parts in this course, we're going to dive into more advanced features such as decorators, generators, and we'll also see how we can web scrape from the net, create user interfaces, and so much more. So there's plenty of stuff to look forward to, so I'll see you in the next section.